Good evening and welcome back. Tonight, we travel to the far end of the map, to a continent of wind and light where ice runs for thousands of miles and the sun can linger for months. Antarctica, nearly twice the size of Australia, is a place of towering shelves, hidden mountain ranges, and silence, so complete it feels like a presence. Some call it forbidden, not by law, but by distance, cold, and the sheer force of nature. What does the ice remember? In its layers lie ancient atmospheres and long winters, a record of Earth written grain by grain. Radar reveals the buried Gamburtsev Mountains. Beneath the ice, lakes like Vostok lie sealed in darkness. On the surface, meteorites wait in blue ice fields. Along the coasts, penguin colonies and hardy seals survive on a knife's edge. While in research stations, scientists from many nations study climate, life, and deep time. We will look at fossils from a greener Antarctica, the story of Gondwana, and the treaties that keep this continent devoted to peace and science. We will also examine the myths and bold claims that say something older still sleeps under the ice, separating evidence from speculation. As always, I'd love to know where in the world you are listening from and what time it is for you. Settle in, breathe a little slower, and let the cold and the quiet carry your thoughts. Let's begin. Begin with a globe from the ancient world. At its crown is the realm of the Great Bear, whose stars gave the North its name. Antarcticos simply meant the country opposite the bear. Long before any keel cut through pack ice, the South existed first as an argument. Greek philosophers imagined balance in nature and in geography. If land dominated the North, then a counterweight must exist below the equator. Aristotle taught a spherical Earth. Eratosthenes measured its girth with remarkable accuracy using two shadows and a desert road. Strabo and Ptolemy codified zones of climate and described an inhabited north and an unknown south. The idea hardened into a premise. To keep the world stable, there must be a great southern continent. Roman writers absorbed the Greek system, and medieval scholars preserved it. The world was pictured as belts, frigid in the far north, torrid at the equator, frigid again in the far south. Between them, the temperate zones where people could live. The far south remained a blank with a name: Terra Australis Incognita, unknown southern land. For centuries it was drawn large because no one could prove it small. Mapmakers called their art a science and a theatre. Where knowledge ended, imagination began. The margin of the south filled with invented coasts and confident captions. In the Age of Faith, the South also stirred a debate over the Antipodes. Were there people on the other side of the world? And if there were, could they be descendants of Adam when ocean girdled the globe? The question braided theology with geography. Some thinkers insisted there could not be human realms hidden so far away. Yet merchants brought cinnamon from islands beyond common charts. Sailors returned with tales of birds that never touched land. Each fragment tugged at the curtain of the South. Far from the Mediterranean, a very different archive of knowledge was being built at sea. Polynesian navigators crossed ocean basins with star paths, swell patterns, cloud forms, and the flight of birds as their instruments. They settled the far islands of the Pacific and reached the high latitudes of Aotearoa, New Zealand. Maori oral traditions speak of a voyager named Hue Te Rangiora, who sailed into regions of fog, dark waters, and white cliffs that moved. Later, scholars have read those lines as poetic memory of icebergs and drift ice. Whether literal voyage or storied warning, the tradition shows that the Pacific peoples imagined and perhaps touched a colder world to the south long before European charts caught up. By the Renaissance, the old premise returned with new force. Print multiplied maps. Compasses improved. Caravels and naos widened horizons. Cosmographers in Venice, Lisbon, Dieppe, and Antwerp stitched traveller reports into master charts. The result still placed a continent in the south, because balance still seemed necessary. Gerardus Mercator surrounded the bottom of his world with a vast southern land that hugged the unknown. Oronce Finet offered a triangular Antarctica with bays and promontories carefully named, yet never seen. The practice was honest in its way. A map acknowledged where knowledge ended by drawing boldly. The South remained theatre. The more explorers found islands and straits in the Pacific, the more they believed a great southern continent must lie just beyond. The Strait of Magellan suggested a barrier. If the Atlantic passed into the Pacific through a narrow throat, then land must arc below it. Dutch ships working the roaring 40s logged seas that ran unbroken for days. They called it the brave west wind. The ocean swelled and the sky lowered, and every instinct told a helmsman that a continent stood not far beyond the horizon. Mariner logic kept Terra Australis large. Religion, commerce, and pride intertwined with this geography. Monarchs granted patents to discover and claim. Private consortia funded voyages in return for whales, seal oil, and the chance of a new spice coast. Scholars in the Republic of Letters traded letters about southern magnetism and the puzzle of the compass that dipped as one sailed south. Natural philosophers wondered whether new constellations ruled new climates. The Southern Cross rose over decks and gave sailors a nightly proof that they had entered another sky. Still, the land that would one day be called Antarctica remained a rumor anchored by mathematics and tradition. Facts accumulated at the margins. Al-Idrisi in the 12th century had compiled a world survey that admitted ignorance south of the known zones. Portuguese and Spanish pilots recorded cold currents that flowed north like rivers. The Humboldt Current chilled the coast of South America, and its strength argued for mighty winds and an engine in the polar seas. Whalers found driftwood from trees that do not grow in Patagonia, and reasoned that rivers from some other shore carried it. In each case, the evidence was indirect, but persuasive. The South existed not yet as a coastline, but as a force. The modern fascination with Antarctica begins here in the interplay of reason and desire. A need for symmetry created a continent in the mind. Courage and curiosity kept it on the map. By the late 18th century, that imagined land became a challenge rather than a picture. To test the premise, men would have to sail into the latitudes where summer has a weak sun and winter erases the horizon. The next act would convert Terra Australis Incognita from conjecture into landscape. Across that threshold, the white continent would emerge not as a paradise, but as a sovereign world of ice, holding most of the planet's fresh water, larger than Europe, and nearly twice the size of Australia. A continent whose past life in warm ages and whose hidden record in ice would one day make it central to Earth history. Picture a scriptorium where parchment smells of glue and lamp smoke. A cartographer pricks a grid onto calfskin with a compass and a needle, then draws rum lines that radiate like starbursts across the oceans. The early world maps were not simply pictures of coasts, they were arguments about how the Earth worked. To many scholars, balance demanded a southern land to counter the known mass of Eurasia and Africa. The name Terra Australis Incognita stood at the bottom edge of knowledge, a promise more than a place. Classical learning seeded that promise. Ptolemy's geography preserved a mathematical Earth with a network of latitude and longitude. Medieval scholars copied his ideas into Mappe Mundi that mixed scripture with geography. Where reports from sailors and merchants thinned, illustration took over. Sea monsters rose from white space to signal ignorance. The great southern land was drawn as a continuous rim because a void on the page felt less honest than blank paper. With the rise of oceanic empires, the blank became a prize. The Iberian crowns guarded master charts known as the Padrón Real, as if they were state secrets. These working maps were updated with soundings, currents, and new headlands as pilots returned to Seville and Lisbon. In the north, the Dieppe school in France produced sumptuous charts in the 16th century that showed a grand southern continent, richly named and wholly imagined. Oronsfein published a cordiform world map in 1531 that wrapped a triangular southern land around the pole and labeled it as recently discovered yet not fully known. The careful language disguised a leap of faith. A few artifacts acquired later fame well beyond their likely intent. The Piri Reis map, drawn in 1513 by an Ottoman admiral, stitched together earlier Portuguese and possibly Colombian sources. Its southern reach sparked the claim that it showed Antarctica free of ice. Most historians read it differently. The coastline aligns more naturally with South America, extended too far south, and misinterpreted around the unknown archipelago at the end of the continent. Yet the very persistence of the claim shows how a blank at the end of the world invited bold readings. The tools of navigation shaped what mapmakers dared to draw. Mariners could find latitude with relative confidence by measuring the height of the sun or familiar stars using an astrolabe, a cross-staff, then later the backstaff and the sextant. Longitude remained elusive until the marine chronometer in the 18th century allowed time to travel. Before that, long east-west distances on maps stretched and sagged. Coasts in higher latitudes wandered like loose threads. In the Southern Ocean, where storms hid the sky and ice drifted like pale cliffs, a captain could not fix position with much precision, which meant the cartographer could not fix a continental edge either. Gerardus Mercator transformed the craft with his famous projection in 1569. He sacrificed true area in favor of straight lines of constant compass bearing, a boon to pilots who plotted courses by direction. His spacious southern margin encouraged the long habit of ringing the map with a continuous terra australis. Abraham Ortelius, who published the first modern atlas in 1570, followed suit with an elegant southern land that helped the map feel complete. Completeness was part of the art. Empty borders did not sell. Even where the south seemed to offer a concrete lead, the ocean answered with riddles. Ferdinand Magellan found the strait that bears his name in 1520, a narrow throat between the tip of South America and a land he took to be part of the Great South. Many assumed a continental wall must arc away from that channel, which inflated Terra Australis on charts for generations. Dutch ships later roared eastward with the westerlies and logged vast reaches of uninterrupted sea. The monotony of waves suggested a deep basin hemmed by land beyond sight. Abel Tasman's great voyage in the 17th century traced the edges of Tasmania and New Zealand and then turned back when a gale and the unknown closed in. Again, glimpses of coast fed the idea of a greater whole just out of view. Evidence also crept onto maps through natural history. Mariners brought back stories of cold currents that knifed north along South America. The Humboldt Current, rich in life, chilled coasts otherwise warmed by latitude. Such energy implied a powerful engine at high southern latitudes. Whalers reported fields of floating ice and logs from far coasts caught in pack, proof that rivers and winds worked a long way from any known shore. The stars themselves announced a different world. The Southern Cross rose above unfamiliar seas. Magnetic compasses dipped and misbehaved, a mystery Edmund Halley studied on his South Atlantic voyage around 1700, producing one of the first charts of magnetic variation. The South tugged at needles and minds alike. Cartouches and marginal notes betray the psychology of the age. Mapmakers often wrote that the southern land was placed to preserve symmetry, to accommodate winds and currents, or to support the philosophy of climate zones. Some inscribed names of bays and peoples that no traveler had met. The rhetoric of discovery preceded the fact of it. This did not mean fraud. It meant that maps were working documents that balanced fact, inference, and expectation. At the bottom of the page, Imagination bore more of the load. The blank also tempted speculation about old knowledge. Renaissance scholars hunted ancient authorities that might confirm whispers of a southern world. They found none that described a real Antarctic shore. Still, antiquarian projects, Islamic scholarship, and the recycling of classical geography lent weight to the belief that an antipodal land must exist. Later readers projected modern desires onto early artifacts. A misread cape or a distorted island became, in fertile minds, a prehistoric survey of an ice-free pole. The distance between cautious inference and romantic claim could be measured in the width of a map margin. As printing spread, so did the public appetite for the marvelous. Booksellers, in Antwerp and Venice, offered atlases that made armchair voyages possible. The southern land became a stage for sea serpents, for speculative city names, for neat borders around the unknown. At the same time, working pilots demanded better coastal detail for the places they actually sailed. This tension produced a curious result. The known tightened with accuracy, while the unknown swelled with certainty. Nowhere did that paradox loom larger than around the Antarctic Circle. By the middle of the 18th century, the science to test the great southern idea had finally matured. Sextants and reliable chronometers reduced the fog of longitude. Hulls were stronger, provisions better packed, and naval states funded true oceanic surveys rather than raids and trading ventures disguised as discovery. The Royal Navy and other powers put astronomers, naturalists, and artists on the quarterdeck. They expected measured skies, collected birds, and sketches of every shoreline, as well as claims and charts. The South moved from rumor to itinerary. The cartographic story of Antarctica, then, begins with honest blanks and necessary fictions. The maps that showed a wide white ring were not errors so much as scaffolding erected while the world waited for ships that could survive the polar seas. Early charts captured the hunch of a continent and preserved it until instruments and men could confirm or deny it. The last line of Terra Australis on a copper plate might have been guesswork, but it kept attention fixed on the polar frontier. That attention would draw an expedition into latitudes where the sun stays low and the sea heaves like a living thing. Soon, the theatrical southern border on the page would resolve into real capes, real islands, and a real barrier of ice that resisted every keel. The story shifts from charts to water. Sails fill, ropes creak, and a wooden hull noses into a southern swell that smells of salt and snow. For centuries, Terra Australis had been a promise at the edge of the page. In the 18th century, it became an itinerary. The Crown and the academies sent mathematicians and mariners into the highest latitudes to test whether the imagined counterweight of the world was real land or a mirage born of symmetry. The prelude to discovery began with fragments. Mariners from Europe pushed ever farther south along the Atlantic and Indian Oceans and returned with reports that were precise in sensation and vague in position. They spoke of a line on the sea where water suddenly cooled and grey fog thickened, where birdlife changed in a day and ice appeared like white cliffs drifting on a black plain. We know this border as the Antarctic Convergence, a circlet of water where cold polar seas dive beneath warmer oceans. The old logs, written with cramped hands in poor light, had already sensed a planetary engine before there was a name for it. There were other hints. In 1739, a French navigator glimpsed a speck of land that was ice-armored and storm-beaten, now called Bouvet Island, a lonely outpost near the path of the great circumpolar current. A few decades later, a Breton gentleman named Yves-Joseph de Kerguelen believed he had found the rim of the southern continent. He returned to Europe with news of a discovery fit for a monarch. When a second voyage called at the same shores in 1773, the truth proved colder. The Island of Desolation, as his men named it, was no continent. It was a wind-stripped archipelago with surf for music and penguins for citizens. The South still guarded its secret. Then came the most systematic test that the age could mount. Britain sent James Cook, a surveyor with a mathematician's patience and a seaman's feel for weather, into the Southern Ocean with 2 stout ships and new instruments. In his cabin lay a copy of the Harrison Marine chronometer, a timekeeper that allowed longitude to be carried from Greenwich to the ends of the Earth. With it, Cook could fix position rather than sketch guesses. His crews ate sauerkraut, wort, and citrus to fend off scurvy. On deck he had artists and naturalists whose job was to record as carefully as sailors measured. If there were a southern continent, this armada of order would find it. In January of 1773, Cook crossed the Antarctic Circle for the first time in recorded history. He described a world of ice islands, low clouds, and a sea that seemed to breathe through fog. In the following seasons, he crossed the circle again and again, threading among floes, pushing south until solid pack ice blocked the way. At one point, he reached beyond 71 degrees south, farther than any known mariner, and stared at a field of ice so wide that it felt like a continental shore. He turned back, only when prudence overcame will. Cook completed a circuit of the globe in the high southern latitudes and proved a devastating negative. If Terra Australis existed as a warm, fertile land, it lay beyond a fortress of drifting ice and endless gale. In his journal, he wrote that the risk of penetrating farther outweighed the hope of gain. Yet, even in disappointment, his notes offered a key. He charted bands of current and wind that today we call the Antarctic Circumpolar Current, the greatest river on Earth, flowing east without interruption around the pole and binding the climate of the planet. The wake of Cook carried other nations south. The last years of the 18th century and the first decades of the 19th saw a steady press of sealers and explorers into newly found archipelagos that cupped the top of the Antarctic Peninsula. South Georgia became a base for sealing and later whaling. The South Sandwich Islands and the South Orkney Islands entered the gazetteers of empire. In 1819, a merchant captain named William Smith, blown off course, sighted a chain of icy islands north of the peninsula. The South Shetland Islands soon filled with rough camps and flags of convenience as men hunted fur seals to near extinction. Along with pelts, the newcomers brought the craft of careful looking. They traced the outlines of bays, sounded anchorages, and learned where the sea iced early and where it broke late. Commerce, as so often, paid for the first drafts of knowledge. Exploration followed profit, and curiosity followed both. In 1820, at least 3 expeditions reported sightings of the Antarctic mainland within a span of months. On a January day, the Russian naval officer Fabian Gottlieb von Bellinghausen, commanding the sloops Vostok and Mirny, wrote of a high ice shore that was not a transient flow but a solid barrier, likely attached to land. A few days later, Edward Bransfield of the Royal Navy, sailing from the new sealing grounds, sketched mountains along the tip of what we now call the Trinity Peninsula. Later in the year, the American sealer Nathaniel Palmer approached the same peninsula and saw a vast coast of ice and rock where charts had been empty. The world had been imagining Terra Australis for 2 millennia. In 1820, sailors finally saw it. Even as the first outlines of the continent entered the logbooks, new kinds of knowledge gathered in the rigging. Naturalists noted the way pack ice formed pancake rims and how pressure heaved floes into ridges that ran for miles. They catalogued penguins by beak and call. Adelie penguins massed in rookeries and defended pebbly nests with comic seriousness. Emperor penguins, discovered a little later, carried their eggs on their feet through a winter that was beyond imagining to anyone who had not felt it. Sealers learned the habits of leopard seals, which hunted in shadow under the ice edge, and of crabeater seals, whose teeth were shaped like strainers for krill rather than crabs. The South taught lessons quickly to those who watched. The environment itself began to resolve into pattern. Navigators learned to read the language of light. A pale glow far off meant ice blink where sun reflected from pack even beyond the horizon. A grey arch above the water could signal open leads. Whales became guides. Where humpbacks fed there were krill, and where there were krill there were likely polynyas, the recurring areas of open water surrounded by ice. Storms arrived with little warning, and the ones that came from the west grew fangs as they ran along the track of the circumpolar current. Icebergs carried stories in their shapes. Tabular bergs carved from vast shelves and drifted like floating plains. Blue streaks meant old compressed ice. Dirty bands meant rock picked up from a grounded shelf or a coastal cliff and carried to sea by a moving glacier. A good captain learned to read these signs and to keep his ship out of the grip of a tightening pack. The impulse to arrange what was seen led to the first coherent maps of the Antarctic fringe. French, British, and American ships added headlands and capes to charts with every season. James Weddell, a British sealer and explorer, pushed unusually far south in 1823, along a gulf of clear water, and reached a new record near 74 degrees south. He described seas so calm that they seemed unworthy of the latitude. Later, mariners would find those waters choked with ice and name them the Weddell Sea in his honor. To the west, down a long finger of land later known as the Antarctic Peninsula, sailors found sounds and straits that eased passage when the pack was kind. These were small openings in a stern geography, but they were how human beings learned to move in a place that was as hostile as any on Earth. Science had already begun to build a scaffold around these experiences. Theories of glaciation that grew from European valleys found their largest canvas in the southern continent. If alpine ice could grind granite into flour and leave moraines like bookends on a valley, what could a continent-sized ice sheet do? Cook's notes on currents and winds encouraged a generation of natural philosophers to consider the South not as a static icebox, but as an engine in motion. The magnetic observations from high southern voyages fed early models of how Earth's field changed with latitude and time. Each small advance chipped at the myth. The continent was no longer a balance point for northern lands. It was a real geological body with its own mountains, its own rivers of ice, its own climate that touched the fate of coasts thousands of miles away. The human story was pure grit at this stage. Ships entered waters where the margin for error was measured in hours. Scurvy was less common than it had been thanks to better diet and a belief in fresh food. Yet cold and exposure took their share. Hulls leaked where ice pressed too hard. Rudders snapped when bergy bits rose under a stern swell. Fires were deadly and rare, for no one wished to light one below decks in a storehouse of tar. Sleep came in snatches, and men learned to move on a deck that could jump with a heavy sea and glaze in an instant. All of this labor served a sober aim. The map had to be corrected. The world needed to know whether the last unknown continent was actually there. By the late 1822, a new reality had settled over the Southern Ocean. The blank on the map had boundaries. A high land existed beneath a fortress of ice. There were coasts framed by mountain ranges and enormous shelves of floating ice that carved into the sea with the reports of cannon. The Southern Ocean was not a trackless waste, but a system of winds and water that could be read and used. The southern continent did not answer the ancient dream of balance. It answered to physics and to weather. It could be visited and skirted and measured, but it would not be taken. This recognition closed the age of conjecture and opened the age of contact. The next chapter would bring men onto the ice itself and would begin to reveal what this continent had been in a warmer time and what it might yet mean for the planet. The first human steps on the Antarctic continent were tentative and full of doubt. The records read like a series of small claims pressed against a great silence. In February of 1821, an American sealer named John Davis noted in his log that he had gone ashore on a stony beach south of the new sealing grounds. His words are spare, and cautious. Later, historians argued over the location and over what counts as the mainland rather than a near island or a grounded floe. The claim remains contested, which feels appropriate for a coast that hides itself behind weather and whiteouts. What is certain is that by the middle of the 19th century, sealers and explorers were landing on islands and peninsulas at the northern edge of the continent. They left boot prints, barrel staves, and bone piles that told a harder truth. The Southern Ocean was becoming a hunting ground as well as a frontier of science. Even as commercial crews worked the rookeries, the navies of 3 nations charted the first long arcs of Antarctic coast. In 1840, the French captain Jules Dumont d'Urville forced his ships through fields of pack and named a bright stretch of coast a daily land for his wife. That same season, the United States exploring expedition under Charles Wilkes sketched a broken line of ice cliffs and rocky outcrops along what would later be called Wilkes Land. In the next year, the British commander James Clark Ross pushed down the great embayment now named for him and found a sight so improbable that his journals read like astonishment. Before his bows rose a ruler straight wall of ice hundreds of feet high that ran beyond the horizon. He called it the Great Ice Barrier. Today we know it as the Ross Ice Shelf. On a clear day, steam and smoke curled from a volcanic cone near his anchorage. Ross named the twin volcanoes Erebus and Terror after his ships. Erebus still smolders above McMurdo Sound and reminds every visitor that the continent is as alive as it is cold. Ross did more than name headlands. He carried geomagnetic instruments and fixed lines of magnetic force at sea and ashore to improve the world map of magnetism. In an era when a compass could drift from true with latitude and time, such work was vital. He also showed where a ship could winter and where ice would crush even the strongest hull. His charts became waypoints for the generation to come. For most of the 19th century, the men who set foot on Antarctic shores were there for skins and oil. The fur seal boom that had exploded in the South Shetlands collapsed as fast as it grew. Hunters turned to elephant seals for their blubber. Whales were next. The Southern Ocean rewarded skill and punished haste. Crews learned the grammar of ice. They watched for tide cracks and for the blue light that meant thin ice ahead. They set anchors in obsidian water at the lee of grounded bergs. They learned that a tabular iceberg can carve without warning and send a low wave across a bay that will lift a ship without effort and then throw it down. They also began to leave records that science could use. Temperatures, winds, dates of freeze and breakup, notes on animal colonies that rose and fell like towns on a frontier. The first confirmed landing that no one disputes came in 1895, when a Norwegian whaling voyage under Henrik Bull reached Cape Adar, at the tip of the long peninsula that points towards South America. Among the crew was a Norwegian of English birth, named Carsten Borchgrevink. He jumped ashore and gathered fragments of rock with lichens clinging to them. That small bundle became a scientific fact of great consequence. Lichens are slow and stubborn. Their presence proved that life clung to the outer edges of the continent, even where wind scours and salt spray cut to the bone. Borchgrevink returned to Cape Adar a few years later at the head of the Southern Cross expedition. In 1899, he and his men built prefabricated huts of Norwegian timber on a shingle beach crowded with penguins. They brought sled dogs from Greenland, the first on the continent, and learned how to live through the polar night with blubber stoves and strict routines. They made the first successful winter on the Antarctic mainland. Their meteorological records, their coastal surveys, and their proof that dogs and human beings could move inland with discipline and care marked a threshold. Antarctica was no longer a place where ships merely touched and fled. It was a place where people could stay, observe, and plan deeper journeys. That same era saw the appearance of a pattern that still defines Antarctic work. Expeditions blended national ambition with a program of science. The Discovery Expedition of 1901 to 1904 placed a wooden bark in safe water at McMurdo Sound and erected huts on Ross Island. Robert Falcon Scott commanded the venture. With him sailed a physician and zoologist named Edward Wilson and a young merchant marine officer named Ernest Shackleton. They were the first to use the steep glacier tongues and frozen sounds of McMurdo as a route from sea level to the high polar plateau. The party traced the Farrar Glacier, mapped new coasts, and found a rookery of emperor penguins whose life cycle challenged every assumption about survival. These birds breed in the dark heart of winter. Males balance eggs on their feet through gales, while females are away at sea replenishing strength. The explorers learned that life had found a way at the coldest edge of the planet. Across the continent, a German expedition under Erich von Drygalski sailed in the Gauss and was trapped fast in the pack for nearly a year. Rather than failure, the enforced stay became a field season. They set up balloon ascents to measure the winds aloft. They surveyed a lonely volcanic hill they named Gaussberg, a black dot on a white plain. They gathered oceanographic data and proved that good science can be done when ships cannot move. A Scottish expedition led by William Spears Bruce worked in the South Orkney Islands from 1902 to 1904, founded a meteorological station at Laurie Island, and passed it to Argentina. That base, now called Orcadas, became the oldest year-round station in Antarctica and a symbol of what continuity can achieve. By this time, South Georgia in the subantarctic had turned into an engine for whaling. A Norwegian captain named Carl Anton Larsen founded a station at Grytviken in 1904. Within a few seasons, the sheltered bays of the island steamed with try-works and echoed with the clang of barrel hoops. The industry would soon eat deep into whale populations and provoke international regulation. It also built a string of ports and workshops that later explorers would rely on for repairs, coal, and men who knew the seas of the far south. The same ships that chased blue and fin whales also carried sledges, timber, and tinned food toward the continent. These first landings and first winters reshaped the map of possibility. Men learned that there were windows when the pack loosened and safe harbors when the wind came off the land. They learned where soft snow hit crevasses and how to read sastrugi, the wind-carved ridges that tell a traveler which way the prevailing weather blows. They learned that a sledge needs careful loading and that a dog team must be fed with predictable rations if it is to pull in bitter cold. They learned that a human body cannot carry enough calories to force a route without regular depots of food and fuel placed ahead of time. They learned that a tent can be a temple of order where wet wool dries and maps stay flat and morale holds. The scientific gains of these early shore parties were real and lasting. Collections of rocks and fossils taken from nunataks and coastal headlands showed that the continent had once been warm and forested. Coal seams lay exposed in the transantarctic mountains. Glossopteris leaves pressed in rock later made the case for a bygone supercontinent that once joined Antarctica to lands far away. Meteorological records from winter nights began to reveal the engine that drives katabatic winds down the slopes and out over the sea. Soundings and tide gauges improved the first sketches of continental shelves around the ice front. Each datum pulled Antarctica from myth toward geology and climate science. Above all, those first deliberate footsteps on the ice established a way of working that every later expedition would refine. Build a base in a safe harbor. Live through the winter with patience and discipline. Learn the trails to the plateau. Stock depots on the routes. Travel in spring when the light returns and the temperatures are still low enough to keep the snow firm. Return before the pack closes. It is not romance, it is method. In the doing, a new chapter opened, and with it, the age of grand journeys that would reach for the heart of the continent. The age of conjecture gave way to the age of ambition. The white interior that had hovered at the edge of maps became the center of a contest that tested planning, physiology, and judgment as severely as any theater of war. Nations sent their finest to a place where sunlight circles the horizon and the cold bites metal and mind alike. The goal was a dot on a globe. The journey was a study in human resolve. Before the sprint, there was the rehearsal. At the end of the 19th century, the Belgian ship Belgica drifted frozen in the pack, with a young Norwegian named Roald Amundsen aboard. The men endured a winter without night relief, and learned what months of darkness and monotony do to spirit and body. In the new century, Ernest Shackleton's British expedition in the ship Nimrod reached farther south than anyone in history. His party discovered a broad staircase of ice that rose from the sea to the interior. It was the Beardmore Glacier, a river of frozen time that gave access to the polar plateau. Shackleton turned back near 88 degrees 23 minutes south, a decision that saved lives and set a sober example. He and his men also climbed Mount Erebus, collected the first coal from the Transantarctic Mountains, and sent a separate party to the vicinity of the South Magnetic Pole. These efforts made a new truth plain. The pole could be reached, but not by pride alone. Into this arena stepped two leaders with different philosophies. Roald Amundsen planned a quiet, precise campaign that treated the South as one treats a high mountain. He had intended to pursue the North, but when rumors hardened into claims by Cook and Peary, he redirected. He sailed the stout vessel Fram to the innermost pocket of the Ross Ice Shelf, a place called the Bay of Whales, where the barrier is grounded and safe. His team dressed like hunters of the far north. They skied on light ash wood boards and drove dogs bred for cold. Their sledges were paired and reworked by the champion skier Olav Bjarland, who shaved weight without compromising strength. Navigators such as Helmer Hansen carried a sun compass and a sextant, and kept a ledger of bearings and dead reckonings so exact that the depots could be found in drift or in gloom. They placed tall black flags and lines of small pennants to widen the visual target. Food was rich and practical. Pemmican thick with fat and meat, biscuits that did not shatter at 30 below, cocoa and seal meat when they could get it. Dogs ate dog flesh, a hard arithmetic that was accepted as the logic of survival. Robert Falcon Scott led the British Terra Nova expedition with a more complicated approach. He established his base at McMurdo Sound, on Ross Island under the volcanic cone of Erebus, a place that was familiar and well charted. Scott believed in a blend of modern engines, Siberian ponies, and human pulling power. The motor sledges failed early. The ponies labored bravely but suffered in cold and on soft snow. They sank where dogs danced. When the animals could go no farther, the men took the traces and hauled with straps across their chests. The plan depended on depots, on timing, and on weather that followed the averages of previous seasons. The averages did not hold. The race began with the spring light. Amundsen's team went out in stages to lay depots along a new route that led from the Bay of Whales up a steep glacier that he named for the geologist Axel Heiberg. The climb to the plateau was swift, and the snow was cold and dry. The Norwegians traveled with a rhythm perfected in the north. Skiers made a steady pace, the lead man measuring distance with a sledge meter and the sun for reference. Dogs pulled light sledges and were fed well. Where crevasses crossed the route, the men probed with poles and bridged with speed and spreading weight. On a wide day, the team could advance more than 20 miles and still cut blocks and build a snug, low wall of snow for the night. Amundsen kept his party small. He chose 4 men to go with him for the final push. The sledge loads balanced, the dogs still strong. At McMurdo, Scott's expedition also went inland to lay supply lines. 1 Ton Depot, a key storehouse for the return, was placed a little short of its intended latitude because of weather and the condition of the animals. It was a small change with large effect. Scott sent an early party under Apsley Cherry Garrard to collect emperor penguin eggs for science during the polar night. an effort that showed courage and devotion, and also drained energy and resources. When the pole journey began in earnest, the Polar Party left with manpower, a few surviving ponies, and hopes that the surface would harden with the cold. The animals were shot as planned, and the loads redistributed. Men hauled sledges that weighed like a small car in deep snow at altitude. The Beardmore Glacier, so grand when discovered, proved a brutal staircase. Sastrugi cut ankles and sled runners. Crevasses gaped where the sun struck. The summit of the plateau lies near 3,000 meters above sea level. The thin air, the extreme dryness, and the cold cause dehydration that can be masked by the lack of thirst. Rationing that looked sufficient on paper ran short in bodies that were working at the edge of human capacity. Amundsen reached the polar plateau ahead and in better condition. He had found a route that avoided the most broken ice and kept a strict pace. On 14 December of the year 1911, 5 Norwegians stood at a place where the compass spins and the sun circles. Amundsen, Bjarland, Hansen, Sverre Hassel, and Oscar Wisting planted a flag, took careful observations, and built a small tent with a message for Scott. They measured the position by sun sights over 2 days to be certain of the mark. Theodolite angles, recorded temperatures, and a neat cairn completed a simple ceremony of accuracy. They turned for home with dogs in good order and a string of depots behind them. Scott and his companions reached the pole on 17 January of the year 1912. The names are carved now into the memory of polar history. Scott, Edward Wilson, Henry Bowers, Lawrence Oates, and Edgar Evans. They found the tent and the flag and the note. They found proof of their rivals' prudence and skill. Wilson sketched. Scott wrote his diary with dignity and pain. They had been beaten by 34 days. They had also spent more energy getting there than their rations allowed for the return. The march back began over ground that was now psychologically heavier and physically harsher. The return was a ledger of loss. Evans, a strong petty officer, fell ill after a fall near the beard of the glacier and died near the foot of the Beardmore. Oates, suffering from frostbitten feet and weakened by a long haul, walked from the tent into a blizzard so as not to slow his friends. The 3 remaining men pushed south across the plateau and down onto the shelf toward their depots. The weather turned worse than any record expected. Temperatures fell lower than the averages for that season. The winds stiffened. The last camp stood less than 12 miles from One Ton Depot, the store that might have saved them if it had been placed a little farther south or if the weather had been a little kinder. When a search party found the tent months later, they recovered diaries and letters that became some of the most powerful documents in the literature of exploration. In those pages, the British expedition left a legacy of science as well as sorrow. Geological specimens collected near the glacier were found beside the bodies. Among them were plant fossils that confirmed the old idea of a warm, ancient Antarctica joined to other lands. While the race to the geographic pole seized headlines, the heroic age was larger than a single goal. Jean-Baptiste Charcot mapped and named along the Antarctic Peninsula with thorough care and ran a hospitable ship that became a floating school of science. Douglas Mawson in the Australian Antarctic expedition led a traverse along a coastline, scourged by the strongest winds measured on Earth. A tragic sledge journey left him alone on the plateau, dragging a sledge through hunger and hallucination for weeks, a survival that strains belief. Elsewhere, meteorologists learned how katabatic winds form when cold, dense air falls from the interior to the sea. Oceanographers measured the deep water that forms around the continent and sinks to ventilate the world ocean. Biologists studied penguin rookeries as barometers of sea ice and krill. The heroic age built a tower of knowledge on a base of courage. So much of the outcome of the polar race came down to judgment about means. Dogs on snow against men and ponies, skiers against boots, A camp that sat on a safe harbor under a smoking volcano against a camp perched at the edge of a moving shelf. The decisions were not romantic, they were practical. They ran through questions of friction and furlongs, of calories and the limits of muscle. Amundsen's genius was a ruthless devotion to what worked in the cold. Scott's greatness was a devotion to science and to duty that inspired service beyond self. The South judged without appeal. By the close of this chapter, the map showed a route from sea to sky across the Beardmore and another up the Axel Heiberg. A line of flags marked a meridian of human effort to 90 south. The cost had been high, but the gain was permanent. The polar plateau was no longer a rumor. It had a measured height, a surface of sastrugi that a skier could read, a climate that could kill in hours, and a meaning that reached far beyond flags and nationality. The story of conquest would give way to the story of survival and of science. Shackleton would soon return to prove that leadership could save men from impossible odds. Fossils carried from the interior would anchor a revolution in geology. The continent would move from a stage of rivalry to a laboratory for the planet. The white continent does not reward haste. It keeps what it takes and gives back only to those who learn its grammar. After the flags at the pole, the story of Antarctica widened into something deeper than records and rivalries. It became a study in endurance, improvisation, and the quiet accumulation of knowledge that would change how we understand Earth itself. Begin with a ship imprisoned by ice. In the austral summer of 1914, Ernest Shackleton sailed the stout three-masted Endurance into the Weddell Sea, with a plan as simple and audacious as any of the age. Land a party on the coast near Vassell Bay, cross the continent by way of the pole, and exit to the Ross Sea, where a companion team would have laid depots across the barrier. The sea closed before the attempt could begin. Pressure ridges rose like city walls. In January, the pack clamped tight. By winter, the ship had become a wooden island set in a moving plain. Men built kennels for the dogs, played football on the floes under a sky of ice crystals, and listened as the hull groaned with every squeeze of the pack. In October, the ascent of pressure broke her back. In November, Endurance slipped under in a spill of crates, cordage, and dreams. And the men began a march that would become a legend. Shackleton called a halt on a small rise of drift ice, a place they named Ocean Camp, and then another called Patience Camp. He cut weight with a captain's ruthlessness, a gold case, and a Bible stay. A banjo stays because song supports morale. The carpenter builds up 3 lifeboats for a long bet on open water that might come when the pack breaks. When the floe finally shattered, the boats took to a sea, crowded with bergs and lined with walls of green ice. After 7 days of rowing and bailing, they reached a scrap of rock and gravel called Elephant Island. It was the first firm ground they had felt in 16 months, and it was no salvation. No ship would stray there. Shackleton chose 5 men for an ocean crossing that any pilot of the day would have called madness. He and Frank Worsley, Tom Crean, Harry McNish, John Vincent, and Timothy McCarthy launched the James Caird, a 7-meter boat, towards South Georgia far to the northeast. They navigated by sun glimpses through storm and snow. Worsley took noon sights with a sextant while waves blew like mountains past the little boat. They reached the wrong side of South Georgia, crossed a surf line that would have splintered a lesser craft, and then Shackleton with Crean and Worsley walked across an unmapped spine of mountains and glaciers from nightfall to morning to reach a whaling station at Stromness. Months later, after repeated attempts through sea ice, they returned with a Chilean tug and took every man from Elephant Island home alive. The continent had beaten the plan. The men had not been beaten by the continent. The rescue is the most famous survival story of the polar regions, but it is not alone. Across the wide Ross Sea, the depot-laying party that had set out to support Shackleton met its own trial. Gale after gale tore their sails and their tents. Scurvy and exhaustion took men to the edge. They placed the depots anyway because duty required it, and because faith in the other party demanded it, though that party would never appear on their horizon. A small wooden cross in the snow above McMurdo Sound stands for the cost of that faith, a reminder that survival in Antarctica is never guaranteed and that courage sometimes keeps its own counsel. Survival taught lessons that would also serve science. The Belgians on the Belgica had already learned some of them 2 decades earlier. Trapped in the pack in 1998 and 1999, they became the first to endure an Antarctic winter at sea. The long darkness brought a sadness that was physical. Men slept too much, avoided light, and dreamed with open eyes. The ship's doctor, Frederick Cook, urged the crew to eat fresh seal and penguin to fight scurvy, a prescription that worked and kept lives from draining away in silence. They cut a channel through young ice with saws and picks in the spring to reach open water. From that hard season came hundreds of pages of magnetic observations, meteorology, and the insight that the polar night changes the mind as surely as the cold changes a rope. The lessons would echo for every crew that came after. Elsewhere, the work of staying alive became the foundation of careful science. Douglas Mawson's Australasian Antarctic expedition built a base at Cape Denison in Commonwealth Bay, a place where the katabatic winds pour off the plateau with a force unmatched on any coast on Earth. The instruments recorded average winds near gale strength for weeks, and gusts that peened nails and turned rope stiff as wire. Mawson's eastern sledging party vanished into a chasm after one of the men and a sledge dropped through a hidden slot that the wind had glazed. The remaining 2 turned back on a traverse that seemed to peel hours from a life with every step. Then one was dead of hunger and sickness, and the other was alone with a sledge, a broken world line, and a hunger that made language thin. Mawson reached the hut a spectre, weeks after the ship had sailed. A small wintering party stayed on, kept records, and made the next year count. From that outpost came oceanography, cartography, and biology that still holds value. The book Mawson later wrote, with a title that tells the truth of his year, is as much a document of weather as of will. Science at the turn of the century did not mean a single discipline. It meant a long list of patient tasks. Meteorologists kept hourly records without missing dawn or midnight. Magnetic observers measured the angle of the needle and the horizontal force again and again, because tiny drifts matter over years. Ice observers logged the dates when bays closed and when the first black water showed again. Oceanographers took soundings and lowered bottles to collect water at depth and measured temperature and salt content. These lines of numbers drawn out over seasons created a first sketch of a system. The data showed that dense cold water forms around the continent and sinks to the abyss as Antarctic bottom water, that then threads through the global ocean. They showed that winds falling from the plateau carry enormous energy into the coastal seas and help create polynyas, the open pools that feed food webs and ventilate the ocean. They showed that the ice front breathes with the year and that ice shelves carve along lines that can be plotted like fault lines on land. Biology found treasures that began small. Apsley Cherry Garrard, a young officer with Scott, joined 2 companions in the dark winter of 1911 on a walk that beggars belief. Their goal was to collect emperor penguin eggs for embryological studies that a new generation of scientists believed might reveal clues to the evolution of birds. The 3 men dragged a sledge across pressure ice in the coldest weeks of the year and climbed to a rookery tucked under a volcanic headland while the wind tried to peel their clothes away. The eggs shattered with the snap of a fall until they found a few they could cradle. They returned with frostbitten faces and a box of ivory ovals that would travel to London. The science they hoped to unlock proved less decisive than they believed, yet the journey itself became a measure of devotion. Their companion book stands today as a testimony to what curiosity will risk when it is armed with method and friendship. Geology used the sledges to very different ends. Where the ice retreated from peaks and ridges called nunataks, parties chipped fossils from shale and sandstone. The Glossopteris leaves that Scott's men carried on their last march were among those plates of evidence. Flat tongues of rock marked with fern-like fronds and thick stem shapes told of coal swamp forests that pushed against warm winds under a long summer Sunday. When such specimens turned up in India, South Africa, Australia, and Antarctica, the idea of a supercontinent moved from speculation to theory. Gondwana had existed. Antipodal lands had been neighbors. Antarctica had once sat in different latitudes beneath forests and rivers, then wandered slowly to its present seat and froze. The cold continent was a time machine. The tools that made survival possible also pushed observation forward. The Nansen cooker fed men with less fuel by using steam heat to simmer a second pot stacked above the first. That meant longer journeys, or more time at a crest to sketch and measure. Lightweight sledges, shaved with care by hands that knew wood saved energy over hundreds of miles. Dog lines perfected in Greenland kept teams from tangling when a crevasse opened. Long skis spread weight and turned a death trap into a passable snow bridge. Even clothing was a kind of instrument. Reindeer fur that shed frost outward proved warmer than the tight weave of cloth that trapped moisture. The best kit was not always the newest. It was the kit that had been tested by people who lived in cold as a matter of daily work. By the 1920s, a new tool altered the scale of the map. Airplanes came south. Sir Hubert Wilkins and Carl Ben Eielson made the first powered flight in the Antarctic Peninsula region in 1928, following coasts that would have taken sledging parties weeks to sketch. That same season, Richard Evelyn Byrd, leading a large American expedition, set up a radio-equipped base at the Bay of Whales and used ski planes to extend reconnaissance across the Ross ice shelf, then flew over the geographic South Pole in 1929 with pilot Bernd Balchen, photographer Harold June, and radioman Ashley McKinley. The view from altitude revealed patterns invisible from the surface. The long tongue of a glacier, the suture zones and flow lines on an ice shelf, the ridges of blue ice where wind abraded snow from an underlying hill. All of this could be seen, photographed, and placed on a chart. Aircraft could not point picks at a fossil bed or read thickness from a drill, but they could guide the slow feet of science to places where time would be best spent. Permanent stations extended the observation record from years to decades. The Orcadas station in the South Orkneys, established by a Scottish party and transferred to Argentina in 1904, kept daily weather logs that would later allow climatologists to see trends rather than episodes. On the other side of the continent, small huts at Cape Adare, McMurdo Sound, and along the peninsula gave biologists places to return to colonies and count. Penguin rookeries rise and fall with sea ice and with the pulse of krill. Long series of counts can reveal what a single season can hide. In a similar way, repeated measurements of sea ice extent and ice shelf fronts cross the threshold from anecdote to climatology. One more story from this era answers the charge that the South is only a stage for disaster. In 1912, an Australian named Frank Hurley hauled a heavy camera through gale and frost and made images that are both art and record. When Endurance groaned and twisted in the grip of the Weddell pack, Hurley climbed the mast and fixed glass plates that captured the ship trapped under a vault of stars. When the ship sank, he dived into freezing water to rescue negatives. He dried them in a tent warmed by a seal oil stove and made the archive that would teach generations how the Weddell Sea looks when it decides to keep a ship. In the small acts of care that preserve memory, science, and story, keep one another alive. The heroic age closes not with a flourish but with a quiet change in method. What began as a contest ended as a collaboration between patience and observation. The continent taught every visitor that survival is a system. It requires discipline in small chores, respect for weather, and a willingness to put knowledge before pride. In return, Antarctica offered a storehouse of facts. It gave us the slow pulse of the global ocean, the proof of a vanished supercontinent, the first climber's path onto the polar plateau, and a measure of what cold and time can do to rock, ice, and life. The next frame of the story would enlarge this work again, from brave parties on sledges to nations bound by a treaty, and to scientific programs that study the planet by studying the pole. The camera pulls back from the quiet of a snow dune to the dark shape of a flying boat roaring above white mountains. It is the winter of 1938 in the southern hemisphere, and a German vessel named Schwabenland has reached the ice edge of Queen Maud Land. On her deck are catapults and 2 Dornier aircraft fitted with skis. Crews launch into air that burns the lungs and begin systematic photo surveys of a coast no European state has claimed. They return with thousands of frames that stitch into long mosaics of ridge and glacier. On charts in Berlin, the images are labeled with a new name, Neuschwabenland, New Swabia, an assertion laid down in ink rather than in stone. Aluminum markers are dropped on selected flights, but there is no base and no overwintering party. The expedition is brief and efficient. A gesture of reach in a world that is sliding toward war. Whaling stations in the sub-Antarctic had already drawn the attention of navies. Grytviken in South Georgia boiled with oil and commerce. Bellows roared, flensing knives rang against bone, and the Southern Ocean fed industries thousands of miles away. That trade made the far south a strategic space as well as a scientific frontier. During the war years, the signs of conflict arrived even here. A German raider torpedoed a British vessel near Kerguelen. Allied patrols watched for U-boats among the iceberg fields. Britain quietly founded Operation Tabarin in 1943 and set up small stations along the Antarctic Peninsula. The huts were modest, and their work was scientific and cartographic, yet the timing and locations also supported sovereignty claims against rising Argentine and Chilean interests. In polar regions, flags and weather logs walk hand in hand. The defeat of Germany in 1945 did not still the rumors. That winter, 2 German submarines surrendered in Argentina months after the war in Europe had ended. U-530 reached Mar del Plata in July, followed weeks later by U-977. Their arrival sparked a legend that would prove unkillable. If these boats could cross an ocean in secret, what else might they have carried, and to where? Stories bred stories. Whispered maps appeared that showed a hidden Antarctic refuge carved under ice, a new Berchtesgaden somewhere in Queen Maud Land. No archive has produced credible plans, materials, lists, or photographs beyond the original pre-war aerial surveys. Yet myth loves a blank, and Antarctica offers blanks as wide as continents. Into that atmosphere sailed the largest Antarctic expedition the world had seen. The United States assembled Task Force 68 for a mission named Operation High Jump. It was a vast armada for peace, 13 ships and about 4,700 men, commanded by Rear Admiral Richard Evelyn Byrd, the aviator who had flown above the pole in the previous decade. The stated goals were practical and ambitious. Train a large force in polar conditions. Test aircraft, ships, clothing, and equipment in an environment that punished every weakness. Establish a temporary base on the Ross Ice Shelf and conduct mapping flights over the continent. And bring home data. Temperatures, sea states, ice thickness, aerial photographs, and lessons written in the margins of logbooks. The fleet divided into eastern, western, and central groups and fanned out along the coast. Sailors cut a harbor in the Ross Ice Shelf and erected Little America 4, a tile of buildings dug into snow and tied down with cables. Ski planes came off decks and landing strips appeared on the ice like chalk marks on a slate. Over the following months, camera crews produced hundreds of thousands of frames. Photogrammetry specialists later turned them into hard information about ice fronts, mountain ranges, and the flow lines etched into the surface of vast shelves. Radar altimeters traced the faint echoes that hinted at the buried shape of bedrock. The expedition introduced a generation of engineers to the simple truth that cold changes everything. Steel becomes brittle at temperatures that leave human fingers wooden. Oils thicken, batteries suffer. A well-designed latch in a temperate harbor can jam when salt crystallizes in an Antarctic gust. Not all lessons were gentle. On a flight in January of 1947, a patrol bomber named George I crashed in poor weather near Thurston Island. 3 men died, and others survived for days among shattered aluminum and snow, while rescue crews searched a wilderness where even a burning flare can vanish into the glare of overcast light. Their story is written in mountaineering rope scars and in the terse prose of recovery reports. It is also a reminder that the Antarctic rewards respect more than heroics. The operation as a whole lasted only a few months and ended sooner than first planned, partly because the season closed and partly because the task force had already gathered far more data than could be processed quickly back home. In the decades since, the public memory of high jump has split along 2 tracks. The documentary record shows a huge peacetime polar exercise that mapped coasts, trained crews, and exposed weaknesses in equipment. Bird spoke to a Chilean newspaper about the strategic lesson any airman could see in the age of long-range bombers. The shortest routes between continents can pass over the poles, and that fact would change defense plans for every nation that could fly far and fast. Conspiracy literature, by contrast, turned an abrupt seasonal departure into an admission of defeat, and an interview about air routes into a warning about unknown enemies from the ice. The gap between those stories is filled with a familiar human ingredient, the desire for drama, where procedure is the truth. Even while high jump sailed, other nations were laying plans that would shape the modern Antarctic. Britain continued its small network of scientific stations in the peninsula region, and with time transformed Operation Tabarin into a permanent civilian survey. Argentina and Chile placed their own bases and developed schools and families around them. One Argentine mother gave birth at Esperanza Station to cement a claim with an act as ordinary as it was political. The Soviet Union would soon send expeditions that crossed the continent and established inland stations on the high polar plateau. Airdrops and tractor trains replaced dog teams for heavy work. In this crowded history, Antarctica changed from a hard-won destination to a field program of many flags. The war stories of Antarctica are therefore twofold. There is the record of real activity, from the German photo flights to the British and Allied presence around whaling ports and peninsulas to the American task force that turned the Ross Sea into a classroom. And there is the overlay of rumor that speaks to deeper human patterns. A blank map is an invitation. A remote coast suggests a refuge. When evidence is scarce, imagination is a generous partner. In the late 1930s and the late 1940s, the South served as a stage for both realities. Engineers and sailors left behind specifications and air photos. Storytellers left behind cautionary tales about how easily we prefer the elaborate when the simple will do. What remains indisputable is the way these years prepared the ground for a new political idea. If the war had taught anything, it was the cost of rivalry without restraint. The very scale of high jump and the parallel efforts by other nations made one fact clear. No single country could lay civil claim to the ice continent without inviting conflict. The next chapter would answer that fact with a treaty that turned a strategic frontier into a shared laboratory. Before that compact could be written, the nations had to learn one another's methods on the ice and accept that the weather is the only true master south of the circle. Out of survey flights and winter huts grew a fragile model of cooperation that endures. The world had just come through a decade of global conflict when a new experiment took shape at the bottom of the map. In place of soldiers with rifles came builders with theodolites and radios, and cooks who learned to bake bread when the air itself seemed made of ice. The International Geophysical Year of 1957 and 1958 became the hinge. 12 nations staged the largest cooperative science campaign ever attempted to that point. They ringed the continent with stations and pushed inland to the very crown of the pole. American Navy Seabees carved a base from the snow at the geographic South Pole and named it Amundsen Scott. The Soviet Union opened Mirny on the coast and Vostok deep in the interior where the winter air can drop below -70. Britain, France, Japan, Norway, New Zealand, Australia, Argentina, Chile, Belgium, and South Africa added their own hard-won footholds. Meteorologists launched balloons into violet skies. Seismologists listened for the steps of the planet in the bedrock. Glaciologists began the long discipline of drilling into ancient ice to read the air of earlier worlds. For the first time, Antarctica felt less like a prize and more like a laboratory. The momentum of that shared year carried into diplomacy. On the first day of December in 1959, the same dozen nations signed the Antarctic Treaty in Washington. It entered into force in 1961 and quietly changed the grammar of geopolitics. Antarctica would be used for peaceful purposes only. Military personnel could support science, but bases and weapons would not. Nuclear explosions and the disposal of radioactive waste were forbidden. Freedom of scientific investigation was guaranteed, and observations and results were to be exchanged. Inspectors from any treaty nation could arrive without notice and visit any station or ship to see for themselves. This last provision mattered. In a continent where rumor outruns the mail ship, inspection turned suspicion into a checklist. Article 4 held the most delicate balance. It set aside sovereignty without erasing it. Nations that had claimed wedges of the ice did not have to renounce their claims, but no new claims could be pressed, and no existing claim could grow. The treaty froze a cartography of rival triangles and replaced it with a circle of cooperation. Real cooperation begins in huts and workshops rather than treaty rooms. The stations built during the International Geophysical Year became year-round communities. At McMurdo Sound, Americans ran a small city with a harbor cut through sea ice each summer to receive cargo. Across the Sound, New Zealanders built Scott Base and kept a precise watch on the same winds and tides. Far to the east, Australians made Casey and Mawson into wind, hardened outposts, and turned the tale of Commonwealth Bay into a program of weather and oceanography that never sleeps. Argentina kept orcadas and raised families at Esperanza. A child born there in the 1970s became an odd footnote in the geography of citizenship. Chile grew its own string of bases along the peninsula and hosted marriages and schools. The Soviet Union pushed inland to build Vostok on the highest and coldest of plateaus, then added Novolazarevskaya and Molodiyozhnaya, and later worked with partners in the same sector. Many of these stations began as national endeavors and matured into shared logistics and shared science. The Council of Managers of National Antarctic Programs formed to swap spare parts, flights, fuel, and advice. An aircraft from one nation might land on the blue ice runway, maintained by another, and carry a field team from a third to a remote camp. The daily work of cooperation turned the grand language of the treaty into practiced habit. Governance widened as experience grew. The treaty parties created a standing forum, the Antarctic Treaty Consultative Meeting, where delegations gather each year to review science, logistics, and environmental protection. Inspectors carry clipboards into machine shops and waste rooms and look under fuel lines for the stains that tell a quiet story. During the 1960s and 1970s, the system added new agreements to protect living things and seas. A convention safeguarded Antarctic seals. Then a broader convention regulated the harvest of fish and krill in the Southern Ocean, as if it were one giant linked ecosystem. The logic was clear. The currents do not respect human borders, and neither do penguins or whales. Monitoring of krill and ice cover and predator numbers became part of the same ledger. By the 1990s, the International Whaling Commission had created a Southern Ocean sanctuary, and patrols on the high seas chased pirate fishing boats that would have gutted stocks in a few seasons if left alone. There was a moment when mining loomed. The price of metals rose, and the old curiosity about what lay beneath the ice returned in a new guise. Negotiators drafted a convention in the 1980s to regulate potential mineral resource activity. Scientists and conservationists argued that the only safe mine in Antarctica was one that never opened. The tide turned in 1991 with the Protocol on Environmental Protection, often called the Madrid Protocol. It placed the environment at the heart of the treaty system, banned mineral resource activity for anything other than science, required environmental impact assessments for projects, and ordered nations to clean up old waste and remove unused structures. Specially protected areas were set aside for rare plants and animals, nesting grounds, and unique geologic sites. Specially managed areas were designated where heavy traffic and complex activities require shared rules. The protocol came into full force in 1998 and rewrote the culture of living at the end of the world. Burn pits and open tips gave way to sorting rooms and backloads. Old dumps were dug up and shipped north. A new generation of field camps ran on more efficient stoves, made water with less fuel, and left lighter footprints when the season ended. While diplomats worked, science made the case for why Antarctica matters to everyone who lives within sight of a tide line. Deep ice cores from Dome C, Vostok, and later Dome Fuji captured bubbles of ancient air and showed the dance between greenhouse gases and temperature across hundreds of thousands of years. The patterns are not smooth. They are pulses and steps that reveal how suddenly climate can change. A British team at Halley Station measured springtime ozone and discovered a hole in the 1980s so large and so regular that it remade environmental policy worldwide. That finding helped lead to the global agreement that phased out the gases that chewed at the sky, proving that a graph made in a corrugated hut on a lonely ice shelf can reach every household on Earth. Oceanographers traced the formation of the dense waters that sink around Antarctica and slide along the seafloor like cold rivers that feed the deep Atlantic and Pacific. Marine biologists counted krill and found that sea ice is not only a barrier, but also a nursery where algae bloom beneath the pain of winter, feeding the tiny crustaceans that feed everything larger. Geologists surveyed buried mountains and learned that the ice sheet hides a range as rugged as the Alps and lakes sealed in darkness and pressure. Each insight became an argument that the treaty was not just a compact of convenience. It was a pact to safeguard a planetary instrument. Inspection and transparency have kept the compact honest. Any consultative party can visit any station at any time. The practice has a human texture. Inspectors shake hands in mess halls and ask to see fuel farms, waste segregation, medical stores, and the log of aircraft and ships. They note deficiencies and praise good practice. Reports are public documents. In a landscape where a spill can travel for miles beneath snow, or a careless fire can erase a decade of careful work, such openness is a form of safety. The habit of sharing data is a cousin to that habit. Meteorological observations flow to global networks. Satellite images of sea ice go to any scientist who asks. A researcher from one nation can work at the station of another with a simple memorandum. In this field, the passport matters less than the plan. Not every tension vanished in the cold. Overlapping territorial claims still exist on the peninsula and in parts of East Antarctica, even if they have been set aside. Some nations emphasize presence by building new stations or lengthening runways, and others worry about how to distinguish science from strategy when antennas rise and air traffic grows. Tourism increased as ships grew safer, and demand for the far south became a quiet feature of the travel economy. Treaty parties responded with site guidelines for landings and rules that limit numbers on shore at any one time. The system bends to new pressures and tries not to break. It helps that the Antarctic still punishes pretension. Weather does not negotiate. Ice does not recognize a flag. A plan that ignores either will fail, regardless of who signs the permits. Not every tension vanished in the cold. Overlapping territorial claims still exist on the peninsula and in parts of East Antarctica, even if they have been set aside. Some nations emphasize presence by building new stations or lengthening runways, and others worry about how to distinguish science from strategy when antennas rise and air traffic grows. Tourism increased as ships grew safer, and demand for the far south became a quiet feature of the travel economy. Treaty parties responded with site guidelines for landings and rules that limit numbers on shore at any one time. The system bends to new pressures and tries not to break. It helps that the Antarctic still punishes pretension. Weather does not negotiate. Ice does not recognize a flag. A plan that ignores either will fail regardless of who signs the permits. The longer arc tells a simple story. A continent that might have sparked conflict became a school for patience. The International Geophysical Year taught that shared hardship can make neighbors out of rivals. The treaty framed that lesson in law and kept a truce credible through inspection and the open exchange of records. The environmental protocol shifted the moral center from conquest to care. In the process, Antarctica revealed its deeper value. It is a climate archive and an ocean valve, a clean lab for astronomy at the South Pole, a cradle for penguins and seals, and a proving ground for how nations might manage a common good. On this stage, the practical work continues. Snow is shoveled from doors. Fuel lines are checked against frost. Radios crackle in the dark hours. Outside, the aurora folds and unfolds in a green curtain, while inside, a student calibrates an instrument that will send a trace of numbers into the pooled knowledge of the world. Begin with a hand brushing snow from a dark stone on a ridge that looks out over a white plain without end. The stone is not ordinary rock. It holds the imprint of a leaf with veins as fine as threads. It is Glossopteris, a seed fern that spread across the southern supercontinent during the Permian Age more than 250 million years ago. That leaf has been found in Antarctica, in India, in South Africa, and in Australia. The match is so exact that it reads like a passport stamp from a time when these lands were joined. The continent we call Antarctica was once a green part of Gondwana, stitched to Africa and Australia and India, crossed by rivers, fringed by swamps, and warmed by a sun that rose low but long on summer days. The ice hides that story well, but it has not erased it. High in the transantarctic mountains, the ice withdraws season by season from nunataks, the bare black peaks that poke through the white. Their geologists have pried open pages of the deep past. Coal seams lie exposed on mountain shoulders, a startling sight in the coldest place on Earth. Coal is concentrated plant life. It means forests stood here and fell here. Scott's party on the return from the pole carried bags of such rock with fossil leaves pressed inside. Those samples, later examined in the quiet of a museum, helped make the case that Antarctica had once been forested and that continents can move like slow rafts on a deep mantle sea. The forests were not like the ones we know today. They were dominated by glossopterids and other seed ferns, by conifer relatives, and by ginkgo-like leaves. At high southern latitudes, trees grew through months of dim winter light and months of near-continuous day, leaving growth rings that are wide and then narrow in patterns that record strange seasons. In the Beardmore Glacier region and near the Shackleton Glacier, paleobotanists have mapped whole stands of Permian trees preserved where they grew. Some trunks are still rooted, silicified into stone by mineral-rich waters that replaced tissue cell by cell. In recent years, teams have found fossil stumps and logs so fresh-looking that you can see wood grain beneath a thin skin of ice. The rings inside those stumps show spurts and pauses that tell a tale of adaptation to polar light, long before ice took the land. Antarctica's lost world did not end with plants. The continent has yielded bones and teeth that fill a roster of ancient animals. On Mount Kirkpatrick, above the Beardmore, field parties found bones of a large predatory dinosaur with a crest of bone over its skull, Cryolophosaurus, dating to the early Jurassic Age around 190 million years ago. Nearby have been found bones of early sauropodomorphs, long-necked cousins of the giants that would later roam warmer lands. On the islands off the Antarctic Peninsula, especially Seymour Island in the north, layers from the late Cretaceous and early Cenozoic hold the remains of marine reptiles such as mosasaurs and plesiosaurs, along with sharks and ammonites, the coiled-shelled cephalopods that rode the last great warm seas of the age of dinosaurs. From those same islands come penguin bones of giants, birds as tall as a person, that swam in Eocene waters rich with fish when the climate was as mild as that of modern-day temperate coasts. Other fossils speak to a chapter that united continents more directly. In Triassic rocks of the Transantarctic Mountains, scientists have found bones of Lystrosaurus, a stout herbivore with a beaked mouth and tusks that lived like a pig and browsed like a goat. Its fossils occur in Antarctica, in South Africa, and in India. The match is not only by shape, but by the age and the sediments in which the bones lie. Taken together, these finds gave Alfred Wegener and the geologists who followed him the comparative evidence they needed. The continents had drifted. What is now the cold tail of the Earth once sat closer to the warm center, and the living things of those lands wandered across plains where ocean now lies under ice. The climate story that surrounds these fossils is no less dramatic than the bones and leaves themselves. Through much of the Mesozoic age, Antarctica was warmer and supported forests even at high latitude. Then plates moved. Australia began to pull away from East Antarctica, and the Tasmanian Gateway opened, changing the way currents moved between the Pacific and the Southern Ocean. Later, the Drake Passage widened between the tip of South America and the Antarctic Peninsula. These openings allowed a continuous river of cold water to circle the pole, the Antarctic Circumpolar Current. That current is the strongest on Earth. It isolates the continent, locks cold air in place, and soon helped grow the first large ice sheets. By the time the Oligocene came, permanent ice had formed on Antarctica. The forests withdrew and the coal beds froze. From then on, the ice would wax and wane with the long beat of climate. But the continent itself had changed nation, from green to white. Even within that long cold, there were warm pulses. Sediment cores taken from the Amundsen sea shelf and from the edges of the peninsula hold pollen and ancient DNA that hint at tundra vegetation in some coastal pockets during the mid to late Holocene. Other cores from older layers show that during the mid-Cretaceous, around 90 million years ago, a rainforest grew near what would have been a high southern latitude, with roots and soil microbes preserved in the chemistry of the mud. These snapshots do not contradict the grand turn to ice. They add texture. Antarctica's climate has swung on a long arc, and the fossils are waypoints in that motion. The living record extends into the ocean. Shell beds and microfossils from the continental shelf tell when the ice advanced across the sea floor and when it retreated. Dropstones, the lonely cobbles that fall from melting icebergs and land in fine marine mud, mark iceberg drift routes across past seas. Foraminifera, tiny shelled organisms, carry oxygen isotope ratios in their shells that capture the temperature of the seawater in which they lived. Cores that hold these microfossils let scientists draw curves of warmth and cold that match the growth and decay of the great ice sheet. The fit between land fossils and sea records is a key reason we can say with confidence that the white world we see today grew out of a greener world, and that the change was driven by plate tectonics and by the new isolation of the pole in a circlet of water and wind. Antarctica tells another story through its birds. Penguins evolved in the south when the climate was warmer and seas were open year-round. Fossils from Seymour Island show that early penguins were both diverse and large, with forms that filled different niches along coasts that looked nothing like the modern ice rim. Over time, penguins adapted to colder water and to life along an expanding ice front. Their lineages record the tightening grip of winter in their bones and beaks, just as the trees recorded earlier seasons in their rings. To open a fossil layer on that island is to lay out a family album for a lineage that still waddles past the boots of visitors at the edge of the modern ice sheet. Some of the most eloquent evidence of warm Antarctica does not come from bones or trunks, but from the texture of the land itself. Glacial polish and striations on bedrock tell of ice flow directions and of long sculpting by ice. But beneath that polish, on summits and ridgelines, are weathered surfaces and ancient soils that formed before ice spread over them. On the McMurdo Dry Valleys, the largest ice-free area on the continent, permafrost holds salts and microbes that persist year after year without liquid water, yet nearby buried soils carry the chemistry of older climates that were wetter and supported a thin skin of life. The contrast between present and past is tight and sobering. The planet can swing from forests to sterile cold in the span of plate motions and slow current changes. Antarctica also enriches the story of mass extinction and recovery. In rocks of Permian and Triassic age, teams have traced the ecological change that followed the Great Dying at the end of the Permian, when most marine species and many land species vanished. The plant record shows a shift from glossopterid-dominated swamps to floras that include seed ferns and conifers of new kinds. Animal fossils show the rise of the hardy Lystrosaurus after the crash, a survivor that spread across southern Pangaea and left skeletons where glaciers now run. To stand in that cold wind with such bones in your hands is to hold a chapter of resilience, written under another Sunday. All of these finds rest on careful fieldcraft made possible by short summers and by logistics that now ring the continent. Helicopters set teams on ridges where stone shows through snow for a few weeks. Sledges carry plaster and jackets for delicate fossils that would shatter if pried too hard in cold rock. Saw blades whine under gloves while the sun circles the sky without setting. Samples travel by icebreaker and aircraft to labs, where microscopes and mass spectrometers pull more secrets from each layer than an earlier age could imagine. In this way, the white continent becomes a library. Its stacks are rock ledgers, and its pages are leaves pressed flat and bones half freed from shale. The catalogue grows every season. The cumulative picture is not a simple elegy for a lost Eden. It is a precise account of a continent that has lived many lives. Warm swamps full of seed, ferns, and coal. Dinosaur-filled river plains under a long summer Sunday marine reptiles in broad embayments. Giant penguins along forested coasts. Then a slow turn as gateways opened, a current began to circle, and the climate of the planet pivoted around the pole. The ice we see today is not a mask laid on a single face. It is the newest guise of a land that has changed with the deep rhythms of Earth. The clearest library of Earth history is not bound in leather. It rises in silence above a white desert and keeps its pages pressed in blue ice. Snow falls, air is trapped, and the year is sealed. Next year it happens again. Layer upon layer, the ice sheet builds a ledger of wind, dust, ash, salt, and the breath of living things. When scientists drill a slender core from that vault and lift it into the light, They hold a timeline that reaches far beyond written memory. Begin with bubbles. Each fleck of ancient air is a sealed sample of atmosphere. In the deep cores from Vostok and Talos Dome and Dome Fuji, and in the famous core from Dome C, researchers have measured the rise and fall of carbon dioxide and methane across hundreds of thousands of years. The pattern is not random. Temperature and greenhouse gases move together through a rhythm of ice ages and interglacials set by slow changes in Earth orbit and tilt. At Dome C, the record stretches to about 800,000 years. In the cold stages, carbon dioxide sits near 180 parts per million. In warm intervals, it climbs toward 280. Those numbers repeat like stanzas. In the present day, we are above 400, a value the ancient bubbles never reach. The cores make the comparison plain. The past speaks, and the difference is stark. Isotopes tell temperature. The water molecule can carry a heavier form of oxygen and a heavier form of hydrogen. How much of each arrives in snowfall depends on the temperature of the storm and the path of moisture through the atmosphere. By measuring the ratios in each layer, glaciologists draw a curve of warmth and cold. Dust tells distance. In cold, dry times, the great southern deserts and the Patagonian plains loft fine minerals that settle out over Antarctica. In warm, wet times, the dust fades. Sea salt marks storms and sea ice. Sulfate and volcanic glass mark eruptions. In the Vostok ice, there are chemical peaks that match great volcanoes in far places. Tambora in the early 19th century, with its year without a summer. Krakatoa in the late 19th century. Unknown giants from earlier millennia that shook sky and sea and left a thin grey line in the ice over the South Pole. Not all signals come from above. The ice itself flows, and where it runs past bedrock it can trap tiny crystals and trace metals that hint at the continent below. Radar hauled on sledges and flown on aircraft penetrates the ice sheet and returns the echo of the buried land. From these surveys, a hidden world has emerged. The Gamburtsev Mountains, a rugged range the size of the Alps, sit entombed beneath the center of East Antarctica. Vast valleys and plateaus carved long before the ice arrived are now locked in darkness. Beneath the ice lie lakes that have not seen the day for perhaps 1 million years. Lake Vostok is the largest, a body of fresh water bigger than many of the world's famous lakes, sealed under nearly 4,000 meters of ice. The water rests under pressure and barely moves, warmed by the heat of Earth and insulated by the ice above. Near Vostok, sensors have found a strong magnetic anomaly. The likely answer is unusual geology. To others, it has seemed like a clue to something stranger. In science, the richest story is almost always the one that can be tested. Teams have drilled to the shallow lakes of the West with sterile tools and have found life. In Lake Whillans, they brought up water and mud that hosted microbes eating rock and breathing chemistry in complete darkness. Life can thrive in isolation with no sunlight if there is energy and time. The ice sheet also captures the history of our star. Sunstorms shower Earth with particles that strike the upper atmosphere and create rare isotopes such as beryllium-10 and chlorine-36. These appear as faint spikes in the snow record during periods of high solar activity or when Earth's magnetic shield weakens. In this way, the ice is a sky diary. It also carries the whisper of the cosmos. Every year, micrometeorites dust the planet. In Antarctica, many of these tiny visitors become locked in ice, and then, where wind ablates the surface in blue ice fields, they weather out and collect. That is why search teams on snowmobiles can find meteorites by the hundreds along the flanks of the Transantarctic mountains. Among them are stones from Mars and from the Moon, ancient shards that fell long ago and lay preserved by cold and wind. In the Allen Hills, a team in the 1980s found a Martian stone with mineral features that sparked a famous debate about possible fossil life. The argument sharpened techniques, which is the best outcome such debates can have, and the blue ice still gives up new stones each summer. There are deeper questions the ice can answer, and scientists are working toward them now. The aim is to recover ice that is older than 1 million years, old enough to capture a shift in the pacing of the great glacial cycles. Before that threshold, the swings in climate followed a shorter beat. After it, the cycles stretched to longer intervals. The reason is still argued. Changes in ice sheet dynamics, changes in the shape of Earth's orbit, changes in the coupling of ocean and atmosphere. The only way to know is to read older pages. Drilling projects have surveyed sites where the flow is slow, the snowfall is low, and the ice may be old enough to keep the story intact. Cores from such sites will not just add years, they will change the questions. The ice holds records of fire and flood at smaller scales too. Long continuous cores capture the sulfur haze from volcanic winters and the soot and nitrate marks of changing biomass burning as forests wax and wane on continents. They capture the arrival of lead and other pollutants during the industrial age, and their decline when cleaner fuels and better laws took hold. They reveal modern sea salt patterns that march with the expansion and retreat of sea ice, a dance that rules the lives of krill and penguins. In West Antarctica, high-resolution cores from the divide between the Ross and Ronna embayments show abrupt shifts in snowfall that match changes in wind belts and ocean fronts. The ice along the coast of the Amundsen and Bellinghausen seas has taught glaciologists how warm, deep water can sneak under floating shelves, thin them from below, and speed the glaciers that feed them. The archive is not only a history, it is also a lens on the present. Beneath the East Antarctic ice, another story waits in the gravity field. In 2006, researchers studying satellite data described a circular anomaly under Wilkes Land more than 400 kilometers across. One interpretation is a buried impact structure from a colossal asteroid that struck far back in the Permian age, a body big enough to leave a scar larger than the famous crater in Yucatan. If that reading is right, the blow may have disturbed climate and life at a time close to the great extinction that marked the end of the Permian. The idea is bold and remains contested. Data are indirect, and the ice refuses easy access to the rocks that would settle the matter. Yet the possibility reminds us that Antarctica keeps more than one kind of secret. It archives not only air and dust, but also the deepest violence of planetary history. The most important lesson of this time capsule is simple and sober. Earth climate has always changed, and in the past, those changes were paced by slow celestial mechanics and amplified by feedbacks in ice and oceans and greenhouse gases. The ice sheets grew and shrank. Sea level fell and rose by many tens of meters. The cores prove these things in calm numbers. They also show that the present rise in greenhouse gases is not part of that ancient range. It is a new mark driven by the human use of coal, oil, and gas, and by the cutting of forests. The curves have bent away from the page the ice knows. In West Antarctica, glaciers like Thwaites and Pine Island respond to warmer oceans with retreat that can unground them and raise seas around distant cities. Past layers tell how fast ice can move when thresholds are crossed. Those stories are warnings written by water. Antarctica does not speak in headlines. It speaks in layers and in careful counts. Each summer, a camp on a dome becomes a quiet factory of knowledge. Drillers lower a cable into cold darkness and hear tiny pops as ancient bubbles break under pressure in a core barrel. A scientist lays a fresh meter of ice on a table and logs its crystal fabric from grain to grain. Others cut samples for gas, for dust, for trace metals, for isotopes, for tiny shards of volcanic glass. In a workshop half a world away, a mass spectrometer sips a measured breath from a vial and returns a number with many digits and a small uncertainty. From linked routines like these, a picture of deep time comes clear. The White Continent holds the evidence with patience. we must be patient enough to read it well. Begin with a dim reading room and a map laid flat beneath glass. Inked coastlines curve like a memory. At the foot of the page, a great land waits where few had sailed. For centuries, the southern continent existed as a proposition and a hope. In the 20th century, it attracted a different kind of attention. Writers and investigators began to ask whether beneath the ice there might be the footprint of a very old culture. The idea is bold. It is also a test of how we weigh evidence against desire. Two documents sit at the heart of the modern claim. The first is the chart created in the year 1513 by the Ottoman Admiral Piri Reis. It stitched together older sources from Portuguese pilots and perhaps a Columbian voyage into a new view of the Atlantic. Along the bottom edge runs a jagged coast that some readers have called Antarctica without ice. Most historians see a different story. The shapes align with South America drawn too long and pulled into high latitudes. The map is a compilation created at a time when longitude was an art and not a science. It is remarkable for its ambition. It is less remarkable as a precise record of the far south. The second document is the Cordiform World Map, published by Oronce Fine in the year 1531. It shows a vast southern land wrapped around the pole and inscribed with rivers and harbors. Later maps by Mercator and by the Dieppe school continued the habit. A century and more after Fine, the French geographer Philippe Bouache published a speculative map that split Antarctica into two large islands with an inland sea. Modern radar and seismic work has revealed subglacial basins and mountain ranges beneath the ice that do give the continent a complex spine. The match feels uncanny at first glance. Yet, Bouache did not have secret surveys. He followed a chain of reasoning common to his age. Many geographers believed in an open polar sea and imagined how rivers and channels might arrange themselves around the pole. The likeness to what we have since found in outline is a coincidence born of a very general guess. In the 1960s, Charles Hapgood published a thesis that became the lodestone for the Antarctic Atlantis. He argued that the outer shell of Earth can slip as a unit over the interior when ice builds up off-center and throws the planet out of balance. In this scheme, the poles move across the surface suddenly. An advanced culture could have mapped an ice-free Antarctica and then been destroyed when the crust shifted. Hapgood pointed to the Piri Reis chart and to other early maps as hints of forgotten knowledge. Albert Einstein wrote a foreword praising Hapgood's curiosity and the scope of his questions. The core claim did not stand. Geophysics and plate tectonics have shown that continents move slowly on convection cells in the mantle. Paleomagnetism, marine magnetic stripes, and the fit of fossils across now separate lands build a precise record of that motion. True polar wander does occur over very long times as the mass of the planet rebalances. There is no evidence that the crust can skid quickly and no mechanism to support a sudden shift within the span of human cultures. The geological record from Antarctica itself pushes back against a recent ice-free age. East Antarctica has held a stable ice sheet for millions of years. West Antarctica has waxed and waned more dramatically, but even in warm intervals within the last million years, large parts of the interior remained under ice. Ice cores from domes and divides preserve unbroken layers that reach back 800,000 years. Those layers show no sudden thaw of the type that would reveal cities or fields in the heart of the continent. Coastal zones have varied more. The Antarctic Peninsula is milder. During the warmest pulses of the early Holocene, there were longer ice-free summers on some shores, and more vegetation on ice-free rock. Moss banks and algae flourished in small pockets. Seal bones and penguin guano layers mark changes in coastal ecology with climate. These signals tell of episodes of relative warmth. They do not point to a temperate continent at any time in human history. There is a separate line of thought that places Plato's Atlantis far to the south. In his dialogues, the island lies beyond the Pillars of Heracles and falls in a time remembered by priests of Egypt. Some modern authors have moved the island to Antarctica and married the legend to conjecture about crustal slip. The sea level history of the last 20,000 years does not favor the claim. At the peak of the last ice age, global sea level was lower by more than 100 meters. Ice on Antarctica spread farther, and the climate around the pole was harsher than today. An island as large as Plato described would not have lurked under mild skies near the polar circle during that period. The story continues to inspire work in archaeology. The map of the Atlantic basin remains crowded with real candidates for lost coastal sites on shelves now flooded by post-glacial seas. Those searches do not point to the south. Advocates of a very old culture often turn to enigmatic images in the ice to make their case. Satellite photos sometimes show geometric shadows along a ridge or a slope that look too regular to be natural. Careful surveys on the ground and from the air almost always identify these forms as familiar geology. Pyramidal mountains arise where several glaciers carve the same summit and leave a horn. Linear ridges can be the sastrugi carved by the wind. Rectangles are the signature of a carved tabular berg with planes fractured at right angles. In a world of glare and shadow, the mind does the rest. None of this strips the mystery from the continent. It insists that the mystery be earned by patient work. There remains the question of memory. Could knowledge of the far south have survived in older cultures and passed by secret channels to the mapmakers of Europe? This is possible at a small scale. Information moves along trade routes, like a scent on the wind. Polynesian navigators explored deep into the South Pacific and may have seen pack ice or great bergs on ventures south of New Zealand. They carried their knowledge in songs and in star paths rather than in parchment. Islamic cosmographers gathered reports from pilots in the Indian Ocean and the Red Sea, and wrote encyclopedias of the world that admitted uncertainty in the far south. Medieval European porterland charts excelled at coasts and currents well known to merchants and stayed silent on the unknown. A whisper can cross oceans. A detailed survey of a hidden civilization cannot. The kinds of knowledge we see in early modern maps are the kinds sailors bring home from within reach of their supply and their hulls. The most telling argument for or against a lost Antarctic civilization is the absence of physical remains where we have learned to look. Archaeology on land depends on sites that freeze, or dry, or bury quickly. The interior of Antarctica is a vast eroding surface of ice that flows toward the sea and grinds everything in its path. Coastal refuges that have been ice-free for long periods are few and small. On those headlands, science teams have been working for decades. They have found sealers, camps, and the timber of whaling huts. They have found penguin cemeteries and peat-like moss banks that record the climate of recent millennia. They have not found stone cities or metalworks or ceramics from a deep human past. A fair-minded account should leave room for surprises. The continent holds subglacial lakes that have never seen a human eye and mountain ranges that have never been climbed. Caves warmed by volcanoes on Ross Island hold traces of plants and of environments that are warmer than the air above. There are places on the continental shelf where sediments may archive river plumes from a warmer age and where future drills could find things we do not expect. To keep an open mind is not to suspend judgment. It is to set a standard. Claims that change history must meet the weight of evidence that history requires. What endures when the mist of legend lifts is no small thing. Antarctica reshapes our view of human time not because it hides palaces, but because it preserves an older and larger story. It shows that continents wander. It shows that climate swings can redraw the face of Earth. It shows that life adapts and endures at the edge of what seems possible. The ancient world does not need a southern Atlantis to be splendid. It needs a clear-sighted account of how sea and wind and stone have changed the stage on which people act. Begin with a satellite pass over white country. Shadows lengthen along the spine of a mountain and resolve into perfect edges that look too neat to be natural. The image races around the world, and by nightfall a new claim blooms. There is a pyramid under the ice, or an entrance to a hidden world, or a craft frozen in place since a forgotten era. Antarctica lends itself to stories like these. It is vast, it is remote, it keeps its silences. But the closer you look, the more the familiar laws of geology and weather come into view, and they tell a steadier story. Take the famous pyramid photographs. In the Ellsworth Mountains and across other ranges, glacial erosion cuts hard rock from several sides at once. Where 3 or more cirques bite into a summit, they leave behind a horn with crisp ridgelines and triangular faces. Matterhorns exist in many latitudes because ice carves in similar ways wherever it flows. The symmetry can be startling to an untrained eye, especially when low sun throws blue shadow against white slope. The clean geometry tempts the imagination. Yet field parties who climb these peaks report what they always find at high latitude: wind-scoured granite, fern crusts, cornices ready to break, nothing laid by human hands. Another case study lives on the sea. In 2018, a research aircraft photographed a rectangular iceberg drifting off the Larsen embayment. It looked as if a surveyor had drawn the edges with a ruler. The explanation is ordinary physics. Ice shelves fracture along planes of weakness, and those planes often intersect at right angles. A tabular berg carved from a shelf can show a long, straight face and a square corner the way a brick shows a true edge when it splits along a clean seam. Given time and swell, even the most precise corner will round and crumble. The camera had caught a newborn berg before weather had a chance to smooth it. Much of the lore gathers around Lake Vostok, the largest body of liquid water under the ice. Radar and seismic surveys in the 20th century revealed the lake beneath nearly 4,000 meters of ice, a dark world the size of a small country. Gravity and magnetic maps show anomalies in the crust near the lake. The words anomaly and Antarctica make a potent brew. A magnetic anomaly is a difference from the average field. It can arise from iron-rich rocks, from deep faults, or from ancient volcanic bodies. The likeliest explanation for the Vostok signal is geology that predates the ice sheet by many millions of years. When Russian and international teams drilled 2 other, smaller subglacial lakes with clean systems, they found microbes that live on minerals and chemical energy in the cold. Life in the dark does not require visitors from the stars. It requires water, nutrients, and time. Legends also circle Operation High Jump, the vast United States naval expedition of 1946 and 1947. A patrol plane crashed in poor weather, and 3 men died. The season ended earlier than first planned as the austral summer closed. These facts seeded a story that the task force had fought an unknown foe over the ice. The documentary record shows a large training and mapping effort with hard lessons in polar logistics, and a commander who later warned that in the age of long-range aircraft, the shortest paths between continents cross the poles. A sober strategic insight became, in some retellings, a coded message about aerial threats from the south. The distance between those 2 readings is the distance between caution and fantasy. One of the oldest Antarctic myths is the Hollow Earth. In this tale, the planet opens at the poles into caverns large enough to shelter lost worlds. The idea is older than flight and newer than folklore. Photographs from polar orbiters that show a dark oval over the pole in winter have been used as proof. In reality, those voids are places where satellites did not collect data, or where the long night at high latitude created a blind spot in early imaging. The Antarctic Treaty does not hide entrances. It publishes inspection reports and invites observers to any station at any time. A continent run by many nations and visited by thousands of scientists and crew each summer is not a likely keeper of a secret door. Stories about no-fly zones also recur. There are air safety rules around steep mountains and along crevassed shelves where wind shear eats at wings, and there are protected sites for wildlife where low flights are restricted during breeding seasons. There are preservation rules over historic huts. There is no blanket ban over an entire sector for mysterious reasons. Pilots in Antarctica share weather and runway conditions by radio because survival depends on it. In this environment, transparency is not a slogan. It is a custom that keeps people alive. There are lights in southern skies that need no other world to explain them. The aurora australis pulls green and violet curtains across the night when solar storms drive particles into the upper atmosphere. There are also transient glows near the horizon caused by ice crystals that drift in calm air and reflect distant light. To a watcher on the ice edge after months of darkness, a halo around the moon can feel like a message. Instruments record it as optics and meteorology. Both truths can live in the same scene. Wonder does not require invention. Meteorites draw another strand of rumor. The transantarctic mountains host blue ice fields where wind ablates snow and brings old ice to the surface. Stones that fell long ago and sank into snow travel upward with the flow and collect along ridges like game pieces pushed to one side of a board. Teams on snowmobiles sweep these areas each summer and recover hundreds of meteorites. A few come from Mars and the Moon. Their chemistries and trapped gases match what rovers and orbiters have measured on those worlds. One stone from Allen Hills carried structures that some read as microfossils. The claim did not stand in its first form. The debate sharpened methods and taught a generation how to separate biological patterns from mineral textures. On the ice, even the arguments become data. The continent does contain places that feel unearthly. The McMurdo Dry Valleys hold a Martian landscape of salt crusts and rock, where snow evaporates into air without melting. A rusty cataract called Blood Falls pours from the end of a glacier when iron-rich brine meets oxygen and turns red. Under the Ross Ice Shelf, a camera recently watched fish drift in water that never sees the sunday. At the South Pole, scientists listen for the faint pop of neutrinos in a cubic kilometer of clear ice with an array called IceCube. These facts feed the imagination because they are strange and true. They do not need rescue by fantasy. Some regions are closed for good reasons that have nothing to do with hidden machines. Specially protected areas include moss banks that record climate for centuries. There are fragile penguin rookeries where foot traffic would crush nests. There are zones with historic artifacts that can be ruined by a careless hand. Permits and fences exist because a footprint in soft ground can last a human lifetime in this climate. Researchers plan their seasons around these rules because the archive of the South is finite and precious. The persistence of Antarctic myths says as much about us as it does about the ice. We are drawn to patterns. We prefer intention to chance. We bring stories to places that are hard to reach and harder to grasp. Yet Antarctica rewards a different stance. It asks for patience and for method. It pays back with discoveries that are quieter than legends and far more consequential. A layer in a core that marks a lost atmosphere. A fossil tree that grew in summer light near a polar circle under a greenhouse sky. A microbial community that thrives beneath a kilometer of ice. A wave that shows how a shelf responds to an ocean that is a little warmer this year than last. In a place where the air stings and the compass falters, the best guide remains evidence. The continent keeps secrets, but they are the kind that instruments can coax and that minds can test. To stand on a ridge and watch blue shadow cut a pyramid across a slope is to feel the pull of a tale older than science. To climb that ridge and read the scratches in the rock and the grain of the ice is to learn the older tale that stone and water tell together. Both experiences are part of why people return. One feeds wonder, the other builds knowledge. Antarctica has room for both. provided we know which is which. The camera opens on a scroll of names and flags, a living roll call of nations that have sworn to keep a whole continent for peace and science. Today there are 58 parties to the Antarctic Treaty, with 29 of them holding consultative status, the club of countries that actively shape the rules by consensus. In May of 2024, the newest flag joined the list when Saudi Arabia acceded, a reminder that Antarctic governance is not frozen in time. The treaty's own website records both the total and the distribution of powers, and it lists that recent accession in black and white. Consensus is the quiet heartbeat of Antarctic diplomacy. In the annual Antarctic Treaty consultative meeting, measures move only when every consultative party agrees. There is no veto stick to raise, only the obligation to listen longer and draft better until the room breathes out together. That design, simple on paper, has preserved a continental peace for more than 6 decades while letting science lead. The Secretariat describes this very plainly, and the meeting's practice has made it culture. Layered on top of the treaty sits its environmental conscience, the Madrid Protocol. It made the continent a natural reserve devoted to peace and science, and it prohibits mineral resource activities other than research. That prohibition does not silently expire. Article 7 is explicit, and while Article 25 allows parties to call a general review conference from the year 2048, the protocol's own materials and the Australian Antarctic Division both explain that talk of an automatic 50-year sunset is a misconception. The default is protection, and any change would require a very high political bar. On the ice, the rules have a geography you can walk. There are dozens of year-round and seasonal stations spread around the coast and interior, run by national programs that coordinate fuel, food, weather, search and rescue, and hard science with military precision, even when military presence serves only peaceful logistics. Managers of those programs maintain a shared catalogue of facilities and vessels so that a broken traverse in Dronning Maudland can call a neighbour at Troll, Neomaya, or Princess Elizabeth, and a medevac can thread aircraft and blue ice runways across borders that do not exist here. New construction can signal new intent. China's Qinling Station opened on Inexpressible Island in Terra Nova Bay in February 2024 and gives Beijing a year-round foothold in the Ross Sea region, complementing Great Wall, Zhongshan, Kunlun, and Taishan. Analysts note that the station's position and capacity enlarge both scientific reach and political presence. Chinese sources also emphasize the push toward cleaner local power, with wind, solar, and hydrogen integration that is tailored for polar cold. Elsewhere, the question is not always where to build, but whether to build at all. Australia considered a paved aerodrome near Davis Station. Then, after extensive environmental and economic review, decided in 2021 not to proceed. The official project page explains that decision crisply, and it remains a useful case study in how the treaty system weighs access and impact. Antarctic seas are governed through a sister body, the Commission for the Conservation of Antarctic Marine Living Resources, which manages fisheries and seeks to balance food webs already stressed by warming and meltwater. The Commission established the Ross Sea Region Marine Protected Area in 2016, a landmark decision, yet since then, proposals for large new protected areas in the Weddell Sea and East Antarctica have repeatedly stalled because CCAMLR requires unanimous agreement. Reports from 2024 and 2025 describe how that consensus has been hard to reach as member states contest where and how to limit catch and zones. Krill is the small creature that reveals the large dilemma. CCAMLR sets a precautionary catch limit of 5.61 million tonnes across the Scotia Sea. but imposes a trigger level of 620,000 tons until a finer scale allocation is agreed, a safeguard against concentrated pressure in penguin and whale feeding grounds. In 2025, the fishery hit that 620,000 ton ceiling for the first time, forcing an unprecedented early closure, a milestone covered by wire services and conservation groups, and explained in technical notes by CCAMLR itself. The number looks modest beside the total biomass, but the point of the trigger is not volume, it is distribution in space and time. Tourism has grown into a second test. The International Association of Antarctica Tour Operators reported 118,491 visitors in the 2024 to 2025 season, about 5% fewer than the previous year, because one cruise-only operator paused, yet still an order of magnitude higher than a generation ago. IAATO's submission to the 2025 consultative meeting reads like a logbook for an industry trying to discipline itself, and it sits alongside public dashboards that break out landed visits, cruise-only transits, and rare deep field trips. With more people comes more biosecurity. Highly pathogenic avian influenza reached Antarctica in the austral summer of 2023 to 2024, first on sub-Antarctic islands, then on the continent itself. Researchers documented positive cases in squaws and penguins, and the science community with IATO and COMNAP responded with tightened protocols for cleaning gear, distancing from wildlife, and rapid reporting. The papers submitted to ATCM in 2024 and 2025 show how quickly a shared risk assessment can become shared practice. Shipping is governed by an outer ring of global maritime rules adapted for polar hazards. The International Maritime Organization's Polar Code sets design, training, and operational requirements for vessels in polar waters. Antarctic waters have gone a step further on pollution risk, with a ban on the use and carriage of heavy fuel oil in force since 2011. The result is a higher baseline of safety and a lower baseline of spill risk, even as more hulls nose toward the peninsula each summer. Antarctica's transparency is not rhetorical. It is written into Article 7 of the treaty. Any consultative party may designate observers who can inspect stations, ships, and equipment anywhere south of 60 degrees south. Reports go into a public database, and an inspection culture has grown up over decades, a quiet deterrent against non-scientific activity, and a real incentive to keep fuel berms tidy, waste barrels sealed, and science programs documented. The inspection clause is only a few sentences long. It has probably done more for compliance than any patrol. Finally, science itself shapes geopolitics here. The International Thwaites Glacier collaboration is not a flag, yet the British and American teams drilling hot water boreholes and deploying the IceFin robot under a crumbling ice shelf are doing work that informs coastal planning from Miami to Mumbai. The project's own updates stress that Thwaites is set to retreat further and faster through this century, even if a sudden collapse is unlikely soon, which is a policy message disguised as glaciology. The story of modern Antarctica is the story of a system that still works, most days, because the people inside it keep doing the slow, public things that make trust possible. They publish numbers, file inspections, argue over commas, and call a colleague when the wind rises. It is not a perfect system, it is a rare one. Begin at the edge of a floating ice shelf where the sea is black and still and the ice above is a cathedral of blue light. A small robot slips into the water and vanishes beneath a ceiling 200 meters thick. It carries cameras, sonar, and instruments that taste heat and salt. The robot is part of a quiet revolution. We are learning to see the places that once refused every glance. Under ice shelves, warm, deep water creeps inland in narrow layers. It melts the ice from below and carves channels the length of cities. Autonomous vehicles now map those tunnels and measure how quickly the shelf thins. The knowledge is specific and immediate. When the base of a shelf retreats, the glaciers that feed it often speed up. The lesson is written in numbers, but the stakes are coastal and human. The next frontier stands on a wind-packed dome in East Antarctica, where the sky is so dry that stars look close enough to touch. Here, crews lower a drill into ancient ice. The aim is a core older than 1 million years. In the cores we already hold, bubbles of air record 8 long swings between cold ages and warm ages. A deeper core would cross the shift when the rhythm of the ice ages changed, a riddle that sits at the heart of climate science. To find that ice requires patience and geometry. You need a summit where snowfall is slow, flow is gentle, and layers are not folded. The drilling is a craft we have refined over half a century. Cables vibrate in the cold. Core barrels must be watched for the small fractures that steal air. Each meter is logged, shaved, sealed, and shipped in a ballet that never gets easier. The reward is a new page in the story of Earth climate. Beneath the ice sheet lies a landscape as large as a continent because it is one. Radar and gravity surveys have revealed a range in the interior that rivals the Alps, valleys that hold ancient sediments, and lakes sealed from the sky for perhaps 1 million years. More than 400 subglacial lakes are confirmed. In the west, clean drilling into a shallow lake showed a living community that feeds on rock and chemistry in complete darkness. The next steps will be bolder. Engineers are designing probes that can melt down a column of ice, release a swimmer into a lake, and return without contamination. To do that safely is as difficult as any mission in exploration. The prize is a direct look at a biosphere sustained without sunlight, a lesson for understanding where life might persist on icy moons far from our Sunday. The surface of the ice carries its own instruments. Satellites fire lasers at the ice sheet and time the return to the billionth of a second. They send radar pulses across the surface and watch the scatter of energy to map snow and roughness. They weigh the continent by tracking small changes in gravity as ice is lost to the ocean and snow falls inland. When these lines of evidence agree, we can watch the mass of the ice change from year to year and, in places, from month to month. New missions resolve the swirl of the Southern Ocean in unprecedented detail and follow eddies that carry heat against the shelf edge. Machine learning sifts millions of images for new crevasses, surface lakes, and iceberg carving fronts. The continent that once hid behind storms now updates itself to screens in real time. On the coast, the future will arrive as a natural experiment. When a large shelf front carves back, the ocean that lay under ice sees light for the first time in centuries. Scientists hurry to deploy moorings and nets to record the birth of a new ecosystem. Algae bloom in the bright water, krill graze and fish arrive. Penguins test the new edge. In a decade, the community may stabilize or be reset by the next carving. Repeated studies of these windows tell us how fast life assembles after ice retreats and what conditions favor resilience. At the same time, monitoring of the krill fishery continues to move toward finer scales so that catch limits follow the way predators actually feed rather than a simple total across a basin. The link between ice, food, and policy is precise and growing tighter. Astronomy and physics have made the high plateau a kind of space observatory placed on Earth. At the South Pole, a lattice of sensors buried in clear ice listens for the faint light produced when particles from distant galaxies pass through the planet. A neutrino can cross a wall of lead thicker than a mountain and never notice, yet on rare occasions it flashes a signal in the dark. Each flash carries information about violent events far away in time and distance. Nearby, telescopes stare at the ancient microwave glow left from the first light of the universe and search for subtle swirls in its polarization that would hint at how space itself expanded in the first instant. The air at the pole is dry and calm. It gives these instruments a steadiness that mountain sights cannot match. New arrays and ever colder detectors will sharpen their view. Meteorites write a different kind of star story on the ice. The blue ice fields along the transantarctic mountains act as slow conveyor belts. Stones from space that fell long ago become concentrated at the surface where wind removes snow. Each summer field parties fan out in lines and collect hundreds of rocks. Some are ancient pieces of the crust of Mars. Some are chips of the moon. Others come from asteroids that formed when the solar system was young. Cut and polished in labs, these stones hold clues to the earliest chemistry of our system and to the water and organics that later fed life. The ice is a partner in this work. It preserves what would weather away elsewhere. Stations themselves are changing. Engineers are turning them into cleaner islands on a white sea. Solar panels climb the walls to sip 24-hour summer light. Small wind turbines turn in steady coastal air. Microgrids knit batteries, generators, and intermittent renewable sources into a system that burns less fuel. Waste is sorted and shipped north. Old dumps are exhumed and removed. Some stations use hydrogen as a buffer for energy storage in the cold. Others test new insulation and new building forms that shed drifting snow and keep heat where it belongs. The goal is practical and moral. Life support in this climate is hard won, and every liter of fuel kept in the drum is a quieter footprint. Under the ice and rock, another set of questions waits. Seismic lines and magnetic maps suggest deep sedimentary basins that might hold records of rivers that once flowed across a greener Antarctica. Offshore, drills on the continental shelf recover cores that capture when grounded ice first advanced and when it pulled back. These cores contain shells and microfossils that let us date the steps in that dance. With those dates, we can test the models that project how the ice will respond to oceans that warm and winds that change. Where the models match the geologic past, confidence grows. Where they do not, the models change. It is a discipline that admits uncertainty and then works to squeeze it smaller. The coming years will send more eyes south. New radar satellites will measure glacier speed at the scale of small towns. New laser altimeters will watch the rise of surface lakes that form on shelves each summer and can drive cracks downward when they drain. Networks of instruments will sit on the sea floor at the shelf edge and count the pulses of warm water that try to slip under the ice. Balloons will drift with the polar vortex and sample air over the ice cap in the long dark. Each line of data will tie the story of the continent more tightly to the story of the planet. Antarctica has always changed us by enlarging our sense of time and scale. The new work will do that again. A deeper ice core will anchor our place in climate history. A swimmer in a buried lake will show how life survives in worlds without light. A robot under a shelf will tell us how a glacier will behave next year rather than next century. A neutrino captured in the ice will point back to a distant galaxy where a star tore itself apart. Each is a frontier, and together they are a map for how to learn in a place that does not forgive haste. The camera returns to the black water under the shelf. The robot's lights fade to a pair of distant stars. Above, the ice groans, with the slow speech of a living slab. Beyond the horizon, a drill spins, and a telescope listens. The continent is still teaching. We are finally learning to ask better questions.